This is Professor Van Dyke for Health Science. This is the second of 3 videos for week 12, and this is in regard to air quality. We're going to jump right into it with slide 1. With air quality, we're talking about this being defined as the state of surrounding air in terms of purity. So air quality is all the air around you. How pure is it? Because it should be consisting of approximately 78% nitrogen, 21% oxygen, and less than 1% of carbon dioxide, and certainly less than 1% of all other gases like argon and things like that. So impurities can be solids, liquids, gases, and these are going to determine air quality. So we'll talk a little bit about particulate matter. When we think of air quality, we tend not to think of solid things floating around in the air, but certainly this is a substantial air pollutant, like things like dust and things like that are actually in the air. And these can be problematic. So say for instance with people that work around wood dust very frequently, like if you work in a sawmill, it can actually generate nasopharyngeal cancer from breathing those things in. And certainly if you have asthma, if you have bronchitis, things like that, you know how important air quality actually is. Let's move on to slide 2. So when we discuss air quality types, we can be talking about indoor air quality, localized, regional, continental, or global, and we'll go through each one of these kind of one at a time here. So with indoor, we're talking about inside homes and structures. It can be in your office, it can be at your school, but someplace that you're actually inside. And then localized is usually going to be within a few blocks of, like, say, an industrial source that can be releasing air toxins and hazardous air pollutants, which we call HAPs. And then we'll also talk about criteria air pollutants, which we call CAPs. Okay, so if you live right down the street from, say, for instance, maybe a coal processing plant, localized air can be fairly important to you, and it can change rapidly. So with regional air pollution, we're dealing with a geographical or ecological feature resulting from aggregate impacts of emissions. So we can have stationary and mobile sources, and we'll talk about those. So like with the region, think about Southern California. The region of Southern California tends to have higher air pollution, but certainly the Inland Empire, that portion of that region is going to experience more negative air effects associated with air pollution than you would, like, say, in South Orange County and places like that. On to slide 4, we can talk about air quality in terms of the continent. So on a continental basis, we see things like acid rain that can affect parts of North America, pollutants like SOx and NOx from power generating plants that are having chemical reactions resulting in acid rain, and we'll talk a little bit more about acid rain coming up here as well. So definitely continental. Certainly you all remember China during the Olympics. The continent of Asia was essentially being analyzed in regard to its air quality and respect to how it would affect individuals going there. Global air quality. So as you know, we're not what we do here in the United States and what China does in China has a global impact on us. There are no borders that will affect air quality. It basically goes throughout the globe. So if we had a massive eruption of a volcano, it would not be contained within North America, South America, China, these places. It's going to go everywhere. So with global climate change in regard to air quality, as you remember from the last lecture, chlorofluorocarbons can be very problematic, and they will generate holes in the ozone and kill ozone. In the U.S., air pollution control is enforced under the Clean Air Act of 1970 and its amendments in 77 and 90. The amendments in 77 added more criteria air pollutants and began to really create tractionable numbers to say you cannot exceed these numbers in regard to air quality. So in 77 it was refined quite a bit. Number 6, air pollution sources. We're on slide 6 now. We have natural sources and we have human-made sources. With natural sources, yes, you can have things like volcanic dust and storm clouds and certainly forest fires, and then other plants releasing gases and pollens, especially those that cause allergies. But again, with natural sources just are they just pale in comparison in regard to um, what we actually see in regard to the human-made sources. And it's all a question of looking at the numbers. When you see the increases in air pollutants, especially climate changing air pollutants, we see that it's the human-made sources that dominate substantially. I mean, there's just no comparison. So with human-made sources, we have agriculture, residential activities, and industrial processes as well. So what am I doing as an individual? But what are the industries around me doing? And those are very large numbers in regard to making air pollution. On to slide 7. So we have stationary sources. Now I want you to think of these things, stationary and mobile sources. Stationary sources, right, they're not going anywhere. They're staying put. So these are things like fossil fuel burning power plants, petroleum refineries, even food processing plants and other sources of stationary greenhouse gas producing areas that are going to have an impact on climate change. So it's not just greenhouse gases, it can be things like burning specific materials that may generate a waste that is absorbed into the atmosphere, like argon or things like that. Slide 8, these are mobile sources. So again, these are things that are on the move, right? Automobiles, trucks, airplanes, lawnmowers, outboard motors, ships, ferries, lots of stuff here on this list that's going to be moving around. So a mobile source, so if you think about those leaf blowers that you see so frequently, leaf blowers are actually very bad for the environment. It's one of the leading causes of ozone here in the troposphere. So as you remember, we reside in the troposphere. This is that envelope of gas layer that we live in, and ozone's good in the stratosphere, but it's not good here in the troposphere, and a lot of that's coming from these mobile backpack units that will be used to blow leaves around and things like that. So these are the mobile sources. On to slide 9. We have additional human-made sources. So with excuse me, with agriculture, we do still burn crops, use of pesticides and fertilizers, and these will contribute to the human-made sources. We also have residential activities, things that we do at home. So smoke from heating and chimneys, cooking, barbecuing, paint fumes, gases and particulate matter that are released from things that we do, like using cans of hairspray, cleaners, gases from sewage and septic tanks. These can all add, so it's very very additive in regard to all these activities. You put them all together, and you increase the load in regard to what would be considered air pollution. You add all these things together, and air pollution will get worse and worse. On to slide 10. So again, human-made sources continued. We have industrial operations that generate gases and fumes and vapors and particulate matter. And this is one of the reasons that when you go by a construction site, you see a sign that says, if you see dust coming from this area, contact this number. That's because they're making particulate matter, which adds to air pollution. So cleaning agents like Easy Off that you use in your stove, do me a favor, don't ever spray Easy Off into your oven and then stick your head in there and start cleaning it. This stuff is really dangerous, mostly because you need to kind of let it settle down a little bit, spray it in there, and then go do a load of laundry or something like that, and then come back and clean it up, okay? So cleaning agents, certainly a lot of furniture polishes and things like that can contribute by adding materials into the environment that you're breathing in. If you ever walk into a house where they use a lot of bleach, you know it as soon as you hit the door, right? So these are air pollution, indoor air pollution. And then section 2 is vehicles, transportation, cars, trucks, trains. They account for 50% of carbon monoxide, major source, and certainly in the 70s, 70% in 1983, so we're doing a better job. And then NOx and hydrocarbons from petroleum combustion, these are all human-made sources. And then energy use, part 3, we do burn coal still, and this generates carbon monoxide, carbon dioxide, NOx and particulate matter and things like that that can be very dangerous in regard to air quality. Number 11, these are just some air quality legislation pieces. So the Clean Air Act came about in 1963, but it didn't really have any traction to it. And then it was amended in 67. But in 1970, this was where we really started to see criteria air pollutants getting added on. So in 1970, they said, listen, folks, we really need to do a better job of what we're essentially looking at in regard to air pollution. So let's make numbers that say you cannot exceed this in regard to criteria air pollutants. And we'll talk about what those criteria air pollutants are on the next slide. But it also added national ambient air quality standards. So you have CAPS and you have NACs, and I will call those as such throughout the presentation. So with the CAPS, you have things like particulate matter, and we'll talk about those. But also national ambient air quality standards would say we want our air to be at least this clean, and that's those air quality standards. And then in 77, lead was added to the criteria air pollutants because we really found out that lead was bad for you, and we wanted to make sure that people weren't being exposed to leaded gasoline and things like that in the environment. So Clean Air Act amendments of 87 and 90 showed some revisions in regard to the National Ambient Air Quality Standards. So again, CAPS are criteria air pollutants, and NACs are National Ambient Air Quality Standards. So we'll move on to slide 12, which shows a list of the criteria air pollutants, the CAPS. So particulate matter, carbon monoxide. Oh my goodness. I must have some indoor air pollution here. So carbon monoxide, particulate matter, NOx, SOx, O3, which as you all know is ozone, and lead. So again, ozone is good in the stratosphere, but not good here in the troposphere. So keep that in mind. It's a criteria air pollutant. It's actually bad when you breathe it in, but it's amazing at blocking out harmful effects of the sun's radiation. So again, criteria air pollutants are really critical. And then we also have hazardous air pollutants, which are called HAPs. And you can see those listed here. Things like asbestos and beryllium and cadmium and mercury. These are things that you don't want to breathe in. So hazardous air pollutants are also added to the list, but they're not criteria air pollutants. HAPs are not CAPs. CAPs are not HAPs. So make sure you keep those separated in your mind. Criteria air pollutants are the things that we want to focus on most seriously, most severely, because they're more common. We have a lot of dust in the air, and how do we manage that? Slide 13 is showing the respiratory system, and this is where a lot of the issues really begin. So if you have bronchitis, if you have respiratory conditions, if you have asthma, this is where air pollutants really become a problem. So you see the nose and mouth into the trachea, into the bronchial tubes, and then at the end of the bronchial tubes you see the alveoli, which is where the gas exchange occurs, and we'll talk a little bit about that. Slide 14, the alveoli basically look like little clusters of grapes, and the damage to these does not repair, okay? So when you breathe in a lot of air pollutants, these alveoli get damaged and they're never the same, okay? So this is where you start to see things like asbestosis, but definitely a lot of other things as well, silicosis and things like that. This is where it occurs. These alveoli get damaged and they just can't exchange the gas anymore. And this is an image of the alveoli on slide 14. On slide 15, this is a cross section of an alveolus, a single alveolar space. So this is where the gas exchange actually occurs in the alveolus. Okay, so you see the diffusion of O2 going in one direction, and then the diffusion of carbon dioxide going the other way. So the O2 is absorbed into the capillary, and the CO2 goes back into the alveolus to be breathed out. This is very important. When these are damaged, you really create a lot of problems. So if you were to take all your alveoli and lay them flat, cut them in half and lay them in flat, the human body has the alveolar surface space of about a tennis court. And again, when you damage these, the damage is permanent. So smoking that adds tar to the alveolus is very, very bad. And this is one of the reasons that if you do vape, consider that maybe you don't want to be a human guinea pig, essentially, because you're not going to find a whole lot of studies that say that vaping is good or bad, and it was because it was just essentially rolled out to humankind and said, this is a safer alternative to smoking, which it is, but how does it affect individuals? You just don't know until you have a cohort study that's gone for 20 plus years. On to slide 16. This is the respiratory system protective mechanisms. So obviously a big group of bushy nose hairs can be very positive because it's going to collect up those things that you don't want to breathe in, like particulate matter. They're going to get hung up in the nose hairs. And then you have the cilia, which are just inside the respiratory tract leading into the trachea. And then these are basically little hairs that are covered in fluids, viscous fluids, that will catch up more material, and then it will actually raise it back up. And generally these are things that will be expectorated. You can spit these things out, or you can swallow your mucus. As you see with the mucus blanket, which is inside the trachea, it's essentially a continuation of this process. The mucus blanket is going to gather up more material. It's going to move it up into the ciliary ladder, which is those little hairs that are constantly moving, and they're going to bring that material back up. And then finally, last, at the bottom of the trachea, you have the cough reflex, where some of these larger objects are breathed in and then they're coughed directly back up. So this is the protective mechanism for the respiratory system. Now obviously if you're breathing in a lot of asbestos, or if you're breathing in a lot of particulate matter, there's just not enough of a protective mechanism to be able to stop all this. So that's why these things are in place. This is the human form at its finest, based on thousands and thousands of years of development through environmental pressure. On to slide 17. This is the air quality index that was sponsored by the Mojave Desert AQMD. All AQMDs do this, so you can go online and find out the air quality in your area. If you are going to work for a hospital in the future, especially that has a high number of asthma patients, bronchitis patients, pneumonia patients, things like that, make sure you know this site very well, because it can actually help you in staffing. Because if you see that the air quality is bad or unhealthy, certainly between the 100 to 300 range, you may staff accordingly based on the air quality index. And they will think that you're a fortune teller, that you're a wizard, because you understood that there would be a lot of patients coming in with bronchial conditions or breathing and respiratory conditions because of the air quality index. On to slide 18. Let's skip that. Slide 19. Progress in reducing the ozone pollution. So you see that from 76 to 2001 that we are reducing ozone pollution, and that's a very good thing. So on to slide 20. These are some of our hazardous air pollutants. So with the hazardous air pollutants, you see asbestos, which causes lung cancer, benzene, which causes leukemia, beryllium, coke oven emissions, arsenic, mercury, all kinds of stuff on the list of hazardous air pollutants. And these are things that we like to try to monitor and control. So slide 21 is, again, with the hazardous air pollutants, the HAPs. Was refined in 90 and added a lot more hazardous air pollutants. We're up to about 190 in 2003, and we're substantially higher than that now. The second part of this slide, slide 21, is kind of important. It discusses maximum achievable control technology. So they're called MACTs. If you work in a hospital that has an incinerator, it's required to have a scrubber that's going to clean the air from the exhaust, and it's going to capture a lot of these dangerous materials, these hazardous air pollutants. So this is really important. This is why you don't see these large skyscraper stacks, these large stacks that are just blowing out lots of air pollution, is because of the MACTs that are in place, the maximum achievable control technologies. And if you work in a hospital, you really want to make sure that your MACTs are in place and that they're updated. On to slide 22. So this is discussing the formation of acid rain. So, you know, we talked about NOx and SOx being criteria air pollutants, and this is one of the reasons why. So with acid rain, you essentially have rain that is already a little bit acidic at a 5.6 pH, and of course, as you know, the smaller the number, so from 5 to 1, actually from 7 to 1, the closer you get to 1, the more acidic that is. So a lower number, it generates a higher yield in regard to acidic effects. So normal rain's about 5.6, so it's slightly acidic, but you begin to add things like SOx and NOx into the equation. So these are where the rain really gets very acidic. So H2O, which is water, plus SO4 generates H2SO4, which is sulfuric acid. And if you've worked in a chemistry lab, you know sulfuric acid will chew a hole in your hand. So the closer you get in regard to acidic qualities, the worse it is for lots of things. And we'll talk a little bit about some of the effects that it has. So acid rain is bad. So sulfuric acid coming from the addition of SOx, and then we have the addition of NOx, NOx, specifically NO2. So you add water to NO2 and you get HNO3, which is nitric acid. Again, very dangerous, but this is that formation of acid rain. So a lot of sources in regard to generation of these components, coal-powered plants, vehicle emissions, things like that are going to increase the amount of acid rain that we're actually experiencing. Moving on to slide 23, the effects of acid rain. So lots of different stuff going on here. Effects of acid rain, so when it rains, acid rain will come down and it will affect the aluminum that occurs naturally in the soil. Aluminum is toxic to fish. It's going to wash down into the waterways. It's going to get into these aquatic wildlife, and it's going to kill these things that live in lakes and streams. So acid rain will kill fish and reduce the fish population. It also causes injury and slower growth and death to forests. Acid rain will actually kill trees. And then, of course, the ones that we really see, damage to our cars' paint, corrosion to buildings and bridges. This is why we always paint the Golden Gate Bridge. As soon as they finish from one side, they just start back over, because if you left it to the effects of acid rain, it would destroy it. But it also has effects on the human health. So SOx and NOx can actually affect lungs and heart. So as you're breathing these things in, as you're absorbing NOx and SOx, it will have an effect on your body's ability to respirate. And this causes an additional strain on your heart. And then we also have diminishing return on crops. So acid rain is going to kill some of your crops. And that's not good when you're trying to feed that J-curve of human population. So you can kind of see how everything's starting to come together, right? Slide 24, ambient air pollution, health effects. So you have aggravated cardiovascular and respiratory illnesses. So as you remember, as you're breathing in bad air, your body has to work harder. And then you also have speeding up of lung aging and affecting lung capacity. So you're damaging your lungs. So you remember with the alveoli, they can't handle a lot of stress. So it's going to speed up your lungs. It's going to age them. And then number 3, you have damaging lung tissue in the air passageways, so you're going to damage them. And then on to number 4, contribution to lung disease like bronchitis, emphysema, and certainly things like lung cancer as well. So these are problems. These are things that you don't want, and this is effects from ambient air pollution. These things that you see in the ambient air around you. So we can also have biological air pollution as well. So think about like dog dander, things like that. But you also have fungi. Think about black mold, bacteria like Legionella pneumophila, Aspergillus septoria in regard to molds, penicilliums, fusariums, pollens, algae, dust mites. Even like the reason cockroaches are so bad isn't because they can be mechanical vectors, but they actually shed scales from their bodies, and when you breathe it in, it can cause respiratory distress. So lots of things here in regard to air pollution, indoor air pollution. We also have radon gas too. So fortunately here in California, we don't have a lot of radon gas that's seeping in through basements and things like that, but it does affect a lot of homes across the Midwest and on the East Coast as well. So this is a radioactive gas that can be very problematic in regard to indoor air pollution. Slide 27, chemical sources. So again, combustion byproducts will produce carbon monoxide, carbon dioxide, NOx. It can produce hydrocarbons, particulate matter, and other things, and that's coming from combustion, so your stove working properly. And then we also have things like formaldehyde from building materials, and this was the reason that Lumber Liquidators had a massive lawsuit several years ago. So certainly you want to be very careful when you work with cut wood materials and things like that to protect yourself from indoor air pollution. So you remember a new car smell? That was actually off-gassing from formaldehyde in materials, and certainly in the 70s and 80s that was very bad, but those things have been replaced, so now that new car smell is actually good things that you can enjoy. Slide 28, tobacco smoke and asbestos. Tobacco smoke is very bad. That's why you see that now there are signs on campus that say that you can't smoke within so many feet of the entryways to buildings. And certainly with cities like Davis, with UC Davis, they've essentially said that you can't even smoke in your own car. So they really ratcheted that up in regard to tobacco smoke, which is a carcinogen and it's an irritant as well. And then you have asbestos, which is being removed from a lot of buildings. And certainly when you demolish an old building, you have to have a hazmat crew on site to actually remove the asbestos. So slide 29, some control measures. So you have ventilation, which is basically diluting the air. And this is something that's very important to Cal State San Bernardino. They do a great job of ventilating. So the HVAC units at Cal State are extraordinary so that they can dilute any air pollution that's out. And then you have source removal, which is using less hazardous materials like removing formaldehyde. So fortunately we don't use formaldehyde in the chemistry labs anymore. We use formalin now, so that's that source removal. And then you have source modification. You can put in plastic barriers and seal for things like radon. But then on further, you can have air purification devices like air filters, electric precipitators, ion generators, and things like that that work very, very well. They're very efficient. And then finally, behavioral adjustments. So smoke-free zones, keeping things away from the entryways to buildings so that you don't have smoke actually entering into the buildings themselves. So slide 30 we'd already discussed. Slide 31, nothing. 32, nothing. 33, nothing. 34. This is a slide on stratospheric ozone depletion. Gives you just a little bit of information. You can read it. And then slide 35, which is a prelude to control, just kind of gives you some general information. So really from slide 30 to 35, this is just for your review. You can check them out if you want. Again, keep up all the great work. You all are doing wonderful. This is video number 2 for week 12. We're going to do noise next, which is video 3, and it's going to be a lot shorter, I promise. So stay tuned, and we'll get slide 3 ready for you.